For Unit 2 is about transformations, when we're going to do things to images. Now, last time we saw translation, when we were moving things over. So I'm going to start with the instructions that are graph the image of the figure using the transformation given. Once again, Unit 2 is about transformation. Last time we saw translation. Now we're going to see reflection. Now think of a mirror line. Like if you were to look at yourself in the mirror, you look like you're on the other side, you just flipped. So everything gets flipped on the other side of the mirror if you're looking at yourself. Also, keep in mind that if you're really close to a mirror, you look at yourself as if you're on the other side, pretty close as well. But if you are far away from a mirror and you look at yourself, it looks like you're far away on the other side as well. So distances in reflection remain the same. So now let me find what I call the mirror, and I see the instruction here says reflection across the line y equals 1. So reflection across y equals 1. Let me find where is my line y equals 1. In Algebra 1, you learned that the x-axis is also called y equals 0 line. Notice I switched my letter. The x-axis is also called y equals 0. Therefore, the line y equals 1 will be 1 above the x-axis. If it was y equals -1, I would have put it below the x-axis. So let me find first the line y equals 1, which is what I just did. Now, my reflection, I'm going to move everything from one side of the mirror line to the other side. Remember I said distances remain the same. So I'm going to count distance. Let me follow my point E. If I count the spaces from my point to the line, to the mirror line, I see there's only one space. So my point E prime should be the same distance on the other side. So I'm going to say this is my point E prime. If I count the spaces from my point G, I notice there's two spaces, right? I'm counting it towards the mirror line. There's two spaces, so it should have two spaces on the other side. Once again, I said on the other side of the mirror line, not the axis, the mirror line. So that's my point G prime. Let me follow my point F. There's 1, 2, 3, 4 spaces. So it should be 4 spaces on the other side. That gives me my point F prime. If I connect my points, I get like my image, it's flipped. And that's exactly what I was expecting. For the homework, it will be a little bit difficult to graph this. So I'm going to ask you guys for the specific point. I'm going to be asking for the coordinates of a specific point. As an example, I ask you give me the coordinates of G prime. So I just want you to do this thing to G. So I want the coordinates of G prime. If you look at my point G prime, the coordinates are -2, -1. That is all I'm expecting. Give me the coordinates of the point that I ask you. If I ask G prime, that's what I'm expecting, -2, -1. Don't forget to type in the parentheses at the beginning and the end, and don't forget the space after the comma. You don't have to type in G prime, just the coordinates. Let's take a look at question number 20. So we're doing a reflection across the y-axis. So let me find where the y-axis is. This is my y-axis. Another name this line has is the line x equals 0, but I'm going to call it the y-axis. Remember, it is also called x equals 0. Now, I'm going to move everything from one side of the mirror line to the other side. Notice how my figure is on the right of the mirror? So I'm going to move it to the left of it. Count spaces. If I follow the point F, I see there's 1, 2, 3, 4, 5 spaces towards the mirror line. So let me count 5 spaces on the other side. And that's going to give me the point F prime. If I follow the point E, There's 1, 2, 3 spaces. Let me count 3 spaces on the other side, and that's going to give me my point E prime. If I look at my point D, there's 1, 2, 3, 4 spaces. So let me count 4 spaces on the other side, and that's going to give me my point D prime. I connect my points, and I can see that the image looks the same, it just looks flipped. Now, once again on the homework, I'm going to ask you guys for a specific point. Just give me the coordinates of that point. I could be asking in this case for F prime, E prime, or D prime. Just give me the coordinates of that point. My mentality is, if you can do 1 point, I know you can do them all. So that's why I'm only asking on the homework for 1 point. Now let's take a look at number 21. Let me identify the mirror line. It says reflection across x equals 2. So I'm thinking the y-axis is also known as x equals 0. So my line x equals 2 should look like the y-axis. Now, because it is x equals 2, I'm going to move 2 on the positive side. So I'm going to move it 2 to the right. So I get this line. The line x equals 2. Now, because my mirror line goes through my image, my original image, I expect my 2 pictures to overlap. So whatever I'm going to graph, the reflected image is going to be overlapping with this one, just because my mirror line goes through it. So let's see. I'm going to count spaces. If I look at L, I count my spaces towards the mirror line. There's only 1 space, so my point L prime is right there. If I look at my point K, I count the spaces. There's 2 of them, so there's my point K prime. My point M is 1 space away from the mirror line, so it should be 1 space on the other side. There's my point M prime. Now when I connect my dots, seems like my image got reflected, it got flipped, and I know they overlap, but like I said, that's basically what I was expecting. Lastly, let me take a look at question number 22. Reflection across the y-axis. So here it is, the y-axis. I'm going to reflect everything from one side to the other side. If I look at my point K, I'm counting spaces. There's 2 spaces, so make sure you count 2 spaces on the other side. If I look at my point J, is 1 space from the mirror line, make sure you count the same amount of spaces on the other side. My point I count the spaces. Make sure you have the same amount of spaces on the other side. And then my point L, let's see, 1, 2, 3, 4. So I'm going to count 4 spaces on the other side. And that gives me my point L prime. My image got flipped. So to reflect that image is that simple. Count spaces. Now, what you guys might struggle with a little is the rules. When I ask you, write the rule. If I give you the images, like questions 23 and 24, use the points that I gave you. Look at the K's. What I mean plural is K and K prime. Look at K and K prime and find the point in between them, right in the middle. If I do that, I'm going to get this point. So I'm looking for the point right in between K and K prime. Do the same for L and L prime. Let me find the point right in the middle. Look at the points N and N prime. Look at the ends. Find the point in the middle, which happens to be also the one in between the M's. Now notice how my points are all collinear. That means I can make a line that goes through all my points. We can see this line. This happens only on reflection. Like I said, if I do my midpoints and they are collinear, remember collinear means I can make a line that goes through them. That line happens to be the reflection, the mirror line. And this, once again, this happens only on reflection. So the way I'm going to write this rule, because I'm asking write a rule to describe each transformation, I'm going to say reflection across. Don't forget the two S's on across. Now that line is called x-axis. So I'm just going to say x-axis. So reflection across x-axis. And take a look at number 24. I'm going to do my points in the middle. So I look at H and H prime. There. I look at J and J prime. Find the point right in the middle. I look at I and I prime. And I draw a line that goes through them. My points are collinear. I was able to make a line. That tells me it is reflection. Once again, this happens only on reflection. If you don't believe me, go back to the examples of translation, and you will notice that the midpoints are not collinear. Okay, so here, the points are collinear. So I'm going to say this is reflection across. Don't forget to capitalize the R from reflection, but not the A from across. So reflection across that line. The red line, it looks like the x-axis. Remember, another name for the x-axis is y equals 0. Notice I switched the letter. The x-axis is also called y equals 0. This one is 2 below. So I'm going to call this y equals -2. When you're given the graph, the rule is that simple. Find the midpoints. If they are collinear, you have reflection. So say reflection across and then across that line. Now, when I give you only numbers, I don't give you guys the images, I'm going to use some special cases. Now, the special cases, there's 4 of them. And let me graph them right here. The first one is going to be reflection across the x-axis. If I reflect across the x-axis, my xy, my values of x and y, all they're going to do is they're going to become x negative y. So the numbers are not going to switch orders. The only thing that's going to happen is that the y value is going to switch sign. That's what I'm calling negative y. If it was positive to begin with, becomes negative. If it was negative to begin with, becomes positive. All I'm saying is the coordinates, the y value is going to switch sign. That's all it's going to do. That's when it gets reflected across the x-axis. Another special case is when it gets reflected across the y-axis. The values of x, y are going to become negative x, positive y. So the values are not going to switch order. The only thing I'm going to do is the x is going to switch sign. Let me do an example. Looking at question number 23. Look at n. The coordinates of n is, well, not. Let me take a look at m. The coordinates of m are 1, 2. Look at the coordinates of m prime, 1, -2. Notice how the numbers are the same. In that case, the y value switch signs. That's how I know it's easy, the reflection across the x-axis. So those are 2 special cases. There's 4 total. The other case is when I get reflected across y equals x. For us to remember, let me take a look at the graph from number 23. The line y equals x is this. That's the mirror line y equals x. Now, when I reflect across y equals x, my xy, my values of x and y from the original point are going to become yx. So the signs are not going to change. It's going to change the order of the numbers. So the numbers are going to flip. That's the thing. My other case that you guys are going to see is when I reflect across the line y equals negative x. My xy value are going to flip, but also I'm going to switch the signs on both. When I use numbers only, so I'm looking at 25 through 28 on this notes. When I use numbers only, I'm going to use either of these four cases. So let's take a look. I'm not going to follow point K because I see that I'm using the same number. So I don't know if the numbers are going to switch order or not. So point K is not a good point to follow. So let me cross out K and K prime. I'm not going to follow the point J because there's a 0 in it. And I don't know if 0 changes sign or not. So point J is not a good point to follow. I'm going to follow the other points. For this case, let me follow the point H. Notice H is here and H prime is here. So identify H and H prime. So what I'm going to do is I'm going to ask myself, did the numbers switch orders? I see a 5 and a 4, and then on H prime I see a 5 and a 4. So no, to begin with, the order was not switched. Then I ask myself, did any of them switch signs? I look at the x value, the negative 5. It's the same. I look at the 4, at the y value, negative 4 to begin with. That one did switch signs, right? From a negative became a positive. So let me put this minus on the y. Now, in our special cases, the one that tells me that xy becomes x negative y is the x-axis. So I'm going to write reflection across x-axis. Let me take a look at question number 26. Point U point U and point S are not good to follow. Point U is not good to follow because the x and the y value are 3. So I don't know if they switch order or not. So point U is not good to follow. Point S is not good to follow because of the 2's. I don't know if the x and the y get switched places. So point S is not good to follow. So I'm going to follow the point T. I ignore the signs for right now. I see T has the numbers 3 and 1. Like I said, I'm ignoring the signs. I ask myself, T prime, did the order switch? I see that it did. So I'm just going to flip YX. I look at the original X value, 3. And then I ask myself, did the X value switch signs? Did the 3 switch signs? And it did. So I'm going to write negative X. Then I look at the original Y value, negative 1. Then I ask myself, did the negative 1 switch signs? Yes. So then I ask myself, from my rules, there's one that tells me that xy becomes negative y, negative x. And that one is the line y equals negative x. So I'm going to write reflection across y equals negative x. Let's take a look at number 27. Point D is not good to follow because I don't know if the number switches or not. Point C is not good to follow because there's a 0. I don't know if the sign switches or not. So I'm going to follow point B. I can follow A or B. I want to follow point B. Except ignore the signs. Ask yourself first, did the numbers switch orders? I see a 3 and then a 2. On B prime, I see the same order. So I'm going to say X and Y. The numbers did not switch order. Then look at the x value, the 3, the original x value, and ask yourself, did the x switch signs? And then yep, it did, became negative. Did the y switch signs? No, it did not. Then look for the cases where xy becomes negative x, positive y. And then we're going to say this is reflection across y-axis. One last example. Letter H, point H is not good to follow because it has a 0. I don't know if the 0 switches signs or not. Point J is not good to follow because it has a 0. Once again, zeros, I cannot tell if the sign switches or not. And point K is not good to follow for the same reason. It has a 0. So I'm going to follow point I. For the moment, ignore the signs. I see the number, there's a 3 and there's a 1. And I ask myself, did the order switch? And I say, yes, it did. So I'm going to write YX. I'm going to flip the order. The original X was a negative 3. Then you ask yourself, did the X switch signs? No, it did not. Then the original Y is 1. Then you ask yourself, did the Y switch signs? No, it did not. So that means this is reflection across y equals x. When it comes to numbers only, when it comes to rules, when it comes to numbers only, I'm going to use one of the 4 special cases. When I give you guys the graphs like 23 and 24, I can ask you for any line, not just the 4 cases. So that's the review for reflection.